All right, I'm Mickey, and I'm going to do number 3 from 14.2. It says set up and evaluate the double integral to find the volume of a solid bounded by the graph of the equations x squared plus z squared equals 144. So we have x squared plus z squared equals 144, and y squared plus z squared is equal to 144 in the first octant. So when you think of the first octant, we know that we're here, so we're going to have pretty much all positives. So forget the circle, I'm just notifying that we're in the first octave. So from there on out, we're going to have all positives. So if you look on the graph that was given to us, and you look at here, we know that this is going to be in terms of x and z, excuse me, and we know that if we look at it again, you can see that it's a little here. We can also solve for that if we solve for the y portion, because we know we're going to be doing the double integral in terms of dx dz. So we know we're going to want to solve for y. So we know that y squared is equal to 144 minus z squared. We take the square root of that there, take this off, and we know that since again we're in the first octant, we're only going to want the positive. Alright, so looking at the graph again, we know we come here from both sides. We're doing this little, the dA here, in terms of actually dx. Come in all angles. We know this is the dz, we know this is the dx. Again, once we do this, we know that if we're looking at it from the x portion, we know that we're going to come from 0 to this portion of that graph, which we know this portion of the graph is the square root of 144 minus z squared. So we know we go from 0 to the square root positive 144 minus z squared. There we go. And then we know if we solve for plug 0 into y, we can solve for the z bound, which is this guy here. We know we can plug in square both sides, 144 minus z squared plus z over, you get z squared is equal to 144, and we get z is equal to 12. So we know that, or in here too as well, for the z. So we go 0 to 12 of the function we were going to solve, which we know is the square root 144 minus z squared. And then we now can take the integral of that, and we can do, we know that this here is a constant, right? So technically we can pull that out of the first integral. So we can say the integral of 0 to 12 is the square root of 144 minus z squared times the integral of dx dz. So once we have that, we know that this comes from the integral 0 to 12 of times, this would be x square root 144 minus z squared dz from, you know, that is from 0 to the square root of 144 minus z squared. Alright, from there, I'm going to finish it over here. We can go, we know that 144 minus z squared times 144 minus z squared gives us the integral of 0 times 12 times, or 144 minus z squared dz. Take the next integral, we know that we get 144 z minus z cubed over 3 minus, and then we know that these are going to be 0. So we can also just plug in the 12 and the 0, do some quick work. We'll go ahead and erase this. As long as you guys have this written down, it's okay. We know that z is 12. We already figured that out. So I'm going to make a little bit more room. So we have this bounded. Again, let's bring it back over here. We can do 144 times 12 minus 12 cubed over 3, right? Yes. We can go ahead, and since this is 12 cubed, we can rewrite it as 144 times 12 minus 144 times 12 over 3. We can get common denominators here. 3, 3, which gives us 2 times 144 times 12 over 3. This is going to be the answer for the integral dx dz, but it's also going to be the integral for dy dz as well. All right. Thank you.